I'd like to take a couple of minutes to talk about the way you classify your points. We found out how to find possible maximum points by taking the derivative, setting the derivative equals 0, and solving for your variable. And indeed, the premise of this test called the D-test assumes that you've done that. Look, f sub x at your critical point equals 0, and f sub y at your critical point equals 0. So here's the partials equal to 0 at your critical point. All right. You'll notice that I'm only using the A and the B, not the C, and that's typical for this D-test. All right, so the D-test requires that you use all of your second derivatives. So look, fxx times fyy minus fxy squared. Okay, so there's another way of writing this, and I'm just going to summarize that here. So D can be written as, let me zoom in so that you can see. You could say D is fxx at your critical point times fyy at your critical point minus fxy times fyx. When you write it in this form, you can see all of the second derivatives. Twice with respect to x times twice with respect to y. This one is with respect to x, then y, and this is with respect to y and then x. But as we've shown you with the second derivative f sub x of y and f sub y sub x, these two are equivalent to each other, so it's kind of redundant. That's why instead of me writing that, I write f sub x of y, the quantity squared. Okay, so you can see it in either form, where all of the second derivatives are laid out, or you can just square one or the other of those. All right, so with this D-test, it says if you do all of this work, okay, I'm just describing it. I'll show you some examples in the near future. If D at your critical point is positive, this means you need to keep going, and you're going to go to your fxx. If that too is positive, then your critical point yields a local minimum. Okay, this is all right in your note. If D is positive and you go to fxx, then, hold on one second, let me zoom out. Then fxx is negative, then your critical point is a local max. All right, so that's case one. D comes up positive. Here's case two. If D comes up negative, then you're at a saddle point. So if you're at negative D, don't go any further, saddle point. If you have this scenario where D at your critical point is equal to 0, then your point the status is unknown. So the test didn't tell you anything. So what I'm going to do now is I'm going to go back over the 3 problems that I just did in the earlier video. Okay, so hopefully you wrote this down, or you're looking at the work that I provided in your notes. All right, so here's the example that I just did. Okay, so you'll notice I took my derivative, set my derivative equal to 0, and solved for my variable. In this scenario, I got that my critical point is x equals 2, and y equals negative 3, and z equals negative 7. So let me write that down. Okay, I already have it written there. I'm just going to be redundant. So 2, negative 3, negative 17. This is a critical point. This is either a max, a min, or what's called a saddle point. Please see the video for the max, min, and the saddle point. We'll lay out what those are. All right. So let me go back up here. Here's f sub x. Let me find fxx. Okay, so fxx says go to f sub x and take the derivative paying attention to the x's. So that's 2. Fyy says go to f sub y right here. Pay attention to the y's. So that also is 2. It's a coincidence that they are the same. All right, so then fxy says go to f sub x. So where my finger is, pay attention to the y's. There's no y's anywhere in sight. And fyx says go back to f sub y and pay attention to the x's. There's no x's there. So these two should always be equivalent to each other, right? But definitely not the others, sorry. Okay, now according to the D-test, let me show you what D is. D equals fxx times fyy minus fxy times fyx, if you're going to write it out the long way. So then d equals, fxx is 2, fyy, look where my finger is please, 2, minus here, 0, times 0. So this equals 4. Now here's the thing, you have to try to plug in your critical point. Okay, so you're trying to test out what's happening at this point. So you're gonna write d of 2, negative 3, and you'll only use the x and the y, you won't use the z with the d-test. All right, so here's the problem. It's just 4, there's nowhere to plug the 2, there's nowhere to plug the negative 3, d is consistently gonna be positive 4. So let me go to my table, and you guys should have your table in front of you, not table, your rules in front of you so that you can follow along. So look, I tried to plug my critical point into this equation, and when I did, it spit out a positive 4. So I'm on case 1. D at my critical point is positive. So it says if you're in case 1, keep going. Go to fxx. So I'll go over here, and I look, oh, I'm gonna write it down so that my reader is not confused. Positive 2. So fxx, we have to try to plug in x equals 2 and y equals negative 3 in here, but there's nowhere for it to go, right? There's no x here, there's no y there, so this is simply just positive 2. Please show this work, even when you have no place to plug in your x and your y. All right, so let me go back to my information. Case 1, d comes up positive, but when I did fxx, it too came up positive, so there you go. You're looking at a local minimum. So that means that your point 2, negative 3, negative 17 is a local min. Like that. And you're done. Okay, let's try another one. So here's the second problem that I did with you. Okay, let me remind you of work. Take your partial derivatives. Set your partials equal to 0, solve for your variable, and when we did all of that work, okay, notice here's the rest of that. Okay, you guys should have that in your notes. You got x equals negative 2 and y equals positive 2. All right, so let me finish this problem off by checking what my point can be classified as. So negative 2, positive 2, and then whatever z value goes with that, right? So you guys were responsible for finding the z value. How do you do that? You go all the way back up here, right? Plug in negative 2 for the x and 2 for the y. All right, so having said that, I'm gonna try the d-test, but in order to do that, I need fxx, which equals, let's see, the derivative of 4x is 4, right? Plus 0, fyy. Let's go down here. The derivative of this is 6, 0, and 0. Okay, let's do fxy. So up here. So f of x with respect to y. So notice the first two tell you where to go. So let's go here. But pay attention to the y. So this is 2. And f sub y sub x. So let's go to this one. And pay attention to the x's. So 0, 2, and 0. So this 2 is 2, no pun intended. Right? So those two should be equivalent of each other. So your d-test says that you're going to take fxx, you'll multiply it by fyy, and you'll subtract off fxy. I'm going to show you the long version times fyx. Okay, so let's get to it. So then d equals, look, fxx is 4, fyy is 6, minus fxy is 2, and fyx is 2 as well. So what's this? 24 minus 4, this equals positive 20. All right, so this is turning out much like the last problem that I did. I'm gonna keep going. So my d comes up positive. I gotta be careful. I need to try to plug my point in, so negative 2, 2. Even if there's no x and y's, I need to acknowledge that I tried to plug it in, which means, according to my table, that I need to keep going. Let me show that to you. If d comes up positive, keep going. So we go to fxx, right? Not some random spot. It says go here. Fxx equals 4, positive 4 specifically. And fxx, if you try to plug your point in, there's no x or no y in here. And I'm going to give you an example where you will have to make a substitution. But that too is positive 4, so you get the exact same conclusion we had before. Look here, please. If d comes up positive and fxx also comes up positive, then you're looking at a local minimum. So this point, -2, 2, and then your z term, this is a local min.